Hello, my name is Sham Nair. I'm a director for program management with Microsoft Data Group. Today, we're going to talk about Azure DocumentDB, our globally distributed database. In particular, we'll cover how this blazing fast, planet scale NoSQL database enables applications to beat the speed of light. Before we go into the details of DocumentDB, let's talk about why DocumentDB, why a globally distributed database. Let's imagine a scenario where you have an application that you have deployed in the United States. Consider the application and the database to be coexisting in a data center in the eastern United States. If you have your customers or users in United States, in most cases, these users can have very fast access to the data. The data access itself can be under 10 milliseconds because there is no movement of data from the data to the application, and it's coexisting in the same data center. Now imagine your application going viral or your user actually transferring from United States to Australia. In this case, for the user base in Australia, even if the application is deployed in Australia, the data needs to travel all the way from eastern United States to Australia with a 150 to 250 millisecond additional latency just because of network. This is what we call as physics or speed of light in this particular case. How can we cheat speed of light? How can we actually provide these two user bases the same level of experience with respect to latency? One way to do that is to bring the data as close as the application is. So in this case, if the database spans across the globe and the data is globally replicated in Australia along with in eastern United States, both the user bases can actually get the same level of latency, which is under 10 milliseconds. Azure DocumentDB enables this with a built-in global replication model. Additionally, Azure DocumentDB also enables low latency access with its purpose-built database engine, which I'll talk about in detail. Now let's talk about how Azure DocumentDB enables it. Azure DocumentDB is a fundamental Azure service that is available in all Azure regions. With global distribution built in from the ground up, your data is automatically replicated to all the regions that you associate with the database account. And every database account can have from 1 to n number of Azure regions associated with it. With multi-homing APIs, you do not need to worry about redeploying the application in the case of a failover. Azure DocumentDB automatically fails your application over to the next region in the preferred location list that you provide as a configuration. With manual failover, Azure DocumentDB enables you to do business continuity and disaster recovery scenarios with a breeze. Just with the click of a button, you can actually failover from a database in one region to another region and test your failover scenarios. Along with global distribution, Azure DocumentDB is also built for low latency. We guarantee low latency at P99 of your requests. For all reads, we guarantee that it will be under 10 milliseconds. And for all writes, it'll be under 15 milliseconds. How do we do this? By enabling reads and writes to be served from the local region, as well as with a database engine that is write optimized and latch-free, built for SSDs, enables us to provide you the low latency capabilities that these applications seek. We automatically index every document that we ingest at a sustained ingestion rate, and with no need for secondary indices, at the same time providing rich query capabilities, we enable applications to access this data at the low latency levels that we guarantee. For most applications, you will actually be able to find reads to be under 2 milliseconds latency and writes to be under 6 milliseconds latency. You can see all of this in the Azure portal for your own workload. Beyond global distribution and the low latency capabilities that we talked about, another important aspect for applications is the ability to scale. Ability to scale both storage and throughput as required. Applications built need not have the fear of going viral, and as needed, they should be able to independently scale storage and throughput, which DocumentDB allows. You can scale storage from gigabytes to petabytes. With transparent partitioning at the server side, there is no overhead in terms of the application for scaling from gigabytes of data to petabytes of data. Similarly, with functionality like TTL, time to live, you can actually age out older data as required. And all in all, you only pay for the data that you consume at any point in time. With respect to throughput, You can scale throughput from hundreds to hundreds of millions of requests per second. Let's take an example of an application that has some peak hours during certain time of the day. You can provision the application such that you have hundreds of millions of requests per second provisioned during that time of the hour, and back down to 10,000 or hundreds of requests per second during the other hours. And you only pay for the hour that you provision. Let's take the example of a retailer application which during their testing period provisioned high throughput. Then as they figured out that the application was all set, they lowered the throughput to the guaranteed levels that they required. Then as Black Friday came along or the Cyber Monday sale came along, they again ramped up the throughput for the new sale period. Let's talk about a few customers who are actually using DocumentDB at scale. Toyota, one of the largest car manufacturers in the world, uses DocumentDB as a data store for their connected car platform. Ability for DocumentDB to scale, throughput, and storage independently, as well as the ability for fast queries with low latency was one of the reasons why DocumentDB was chosen as the data platform by Toyota for their connected car push. Today, they are still in the early stages of using this platform for a set of cars, and over time, this is supposed to grow in terms of both scale of throughput as well as in terms of scale of storage. Another one of the customers who have been with us from the beginning is Next Games. Next Games has a set of popular games that has been chart toppers in the iOS App Store for a while. Next Games choose DocumentDB as their data store because of the flexible programming model that they could get and the iterative development benefits they could get out of it. In addition to that, the fact that DocumentDB enables limitless scale and the geo-distribution capabilities of DocumentDB enabling users of Next Games to actually access the data with low latency was one of the other reasons why Next Games thought about DocumentDB and used DocumentDB as a data store. Beyond Next Games and Toyota, we have a set of customers in the field of IoT, retail, other SaaS applications, healthcare, finance, as well as a lot of the high-value Azure services and Microsoft services that are betting on DocumentDB for the global distribution needs. Now, let's take a look at a couple of demos that showcases both elastic scale and the global distribution capabilities of DocumentDB. In one of the demo, I want to showcase how easy it is to change from 2,500 request units per second to hundreds of thousands of request units per second, and what is the benefit that we actually get out of it, as well as showcase how easy it is and the benefit of global distribution with DocumentDB. For the demos, I'm going to use the same database. This database is currently configured at a throughput of 2,500 request units per second. This is a globally distributed database that's spanning across 3 distinct regions. Now let's take a look at the code. This is a very simple piece of code that actually is inserting a set of documents in a loop. Let me go and actually quickly build this solution. Go to my application and just run this application. This application is inserting documents in a loop, as I said. And as you can see here, after a while, this application is able to sustain 2,500 request units per second as the provision throughput that I showed you. Let's stop this. Let's go and see what it takes to actually scale the application. In this case, I go to the Scale tab. Let's change this 2,500 to 100,000. Hit Save. Now the collection is actually scaled such that the throughput is configured for 100,000. Let's go back to our application. Rerun the application without any change. As you can see now, the application is able to sustain a throughput of close to 100,000. It's actually a little over 100,000, but over time it'll settle down to about 100,000 request units per second. So that was easy. All I had to do was go to the portal, just scale up the amount of throughput required. You could also do it in the SDK. You could also do it in the REST using the REST APIs. Let's take a look at what it means to be a globally distributed database and what the benefit of a globally distributed database is. go to another application that I have here. This application is actually running in a VM in central US. This application is reading from a database whose first preferred location is central US. Let's just go ahead and run this application. As you can see, this application is able to sustain reads of close to 3 milliseconds. Because the application and the data is residing in the same region, it can sustain that low latency that we guarantee. Let's go to another region. In this case, it's Southeast Asia. And I have the same application that I showed you, reading from the same database that's in central US. Let's run the application here now. This app now has to actually fetch data from a different region. And there is the speed of light problem that we talked about, where it takes about 200 to 250 milliseconds for data to travel from central US to Southeast Asia. How do we make sure that customers in this region also has similar experience? In this case, it's pretty simple. As I showed you at the top, let me uncomment this line. That now makes this application read from its local region. Let's run the application. Now you can see that the customers in this region, or the app in this region, is also able to sustain the same latency of about 3 to 4 milliseconds. This is again what DocumentDB guarantees. Stopping this application. Let me show you what it actually takes for you to add a new region. If you go to the database, this particular database, as I showed you, was configured with Central US as the write region, Southeast Asia as the, and North Europe as the read regions. And when your application was reading from the local region, we were able to get under 10 milliseconds read latencies. If I wanted to add another region, all it takes is just go here, select West Europe, click on it, and West Europe now becomes a additional read region. It's as simple as that. This database can span across all the Azure regions, and one database can make sure that your application can fetch the data from the region that is closest to you. Those two demos was to showcase the ease of both elastic scale and global distribution with DocumentDB. Now let's look at the consistency model supported by DocumentDB. CAP theorem states that if your data is partitioned by network, you can either achieve consistency or availability, not both. DocumentDB provides an intuitive programming model with well-defined, relaxed consistency models for you to choose from. Using these 5 well-defined consistency models, applications can decide how they make trade-offs between consistency and latency, between consistency and availability, and consistency and throughput. We provide guaranteed SLAs for the consistency levels that you actually set. Consistency levels can be overridden on a per request basis. In terms of accessing data in DocumentDB, DocumentDB has support for rich queries in SQL using JavaScript or the MongoDB API. You can add business logic to your DocumentDB database with stored procedures, user-defined functions, and triggers. DocumentDB also differentiates itself from other globally distributed NoSQL databases by providing support for multi-item ACID transactions with snapshot isolation. With features like change feed, you can easily implement Lambda pattern with the lowest TCO that you can ever find. With change feed and Lambda pattern, you can use a single database for both ingestion and query of the data. DocumentDB also has native support for globally scaled aggregates. These aggregates are supported at global scale, as well as it is deeply integrated into the latch-free and log-structured database engine that we talked about earlier. DocumentDB's model is to provide the richest of API access possible for every customer out there. Whether you're using REST over HTTPS or TCP, or using the MongoDB wire protocol, you can use DocumentDB as a native MongoDB database or as a document store as you would do with the DocumentDB APIs. Now, the API model also means we provide support for most of the common languages, frameworks out there, be it Node.js SDK, support for Spark, support for ODBC, or Xamarin, .NET Core, or Python. We have client libraries, SDKs, tools, and frameworks that allows every developer to use their favorite tools and technologies and frameworks to access DocumentDB as a multi-model database. With the support for MongoDB, we actually include a rich set of MongoDB tools, frameworks, IDEs, as well as community to work with DocumentDB as a native MongoDB database. To summarize, if you look at the need of a modern application in the cloud-first, mobile-first world, these applications care about variety of data, the volume of data, and the velocity of data. With a multi-model capability built into the database, a schema-free NoSQL database, as well as support for SQL, JavaScript, and MongoDB API, allowing for limitless scale of both storage and throughput, and providing the best-in-class, lowest TCO of any distributed database out there with durability guarantees and predictable performance model and global distribution, DocumentDB enables every application to achieve the fast performance as well as the distributed capabilities it requires and beat the speed of light between networks. All of this is provided by DocumentDB with 4 nines of SLA for availability, throughput, latency, and consistency, along with built-in security and compliance at the Azure level. It's very easy to get started with DocumentDB. At documentdb.com, you can get access to the Azure portal. And in the Azure portal, you can get started with a new DocumentDB database and use one of the included samples to try it out. Even easier is to use the DocumentDB emulator, which is a high-fidelity service emulator that you can download onto your desktop or a laptop and use the included samples and work in your local environment. Thank you.